I haven't actually heard Nico say anything, so I'm not sure if Nico can hear us.
Oh, wait, maybe it was already recording. Oy.
I can hear you, and that explains why
Oh,
no one's answering
yep,
me.
I can hear you now.
Okay, I had my microphone set to the wrong microphone. But I kept saying things, and people would make comments that were like plausibly in response to me, but not obviously so, and it was very confusing. Okay, that all makes more sense. Oh, great. Everyone signed up for your roles and everything. You all are fantastic. Okay, let's go. So scheduled meetings. Just wanted to remind everyone that next week we have the RFC Backlog Bonanza recap, where the plan is to go through the Dropbox paper and figure out what we actually did and didn't do, and do those things, and then what we're going to do next if we have time. Then Shepard's 4.0 triage update. I still have to prepare the doc for that, and the atomic bomb. And we made the rule that we should try to have these docs at minimum the day before in today's meeting. Although I think if you want to do earlier, no one will complain. Okay, action item review. I went over this already. Actually, I did this. Is any of these things, should they be checked off that weren't? Taylor, Felix, reading?
I'm about done with one of them.
Okay, I'll let you check it off when you're done. Great. So the deref patterns thing has been accepted. And I created a tracking thing, but I realized I don't remember if we had a liaison planned. I would like to have somebody who's responsible for that, and I would like it to not be me. Just to be the person who forwards messages and so forth and tracks what's going on. Josh, are you someone who wanted to do that? I feel like it was you and Scott who were kind of around on this, but I could be wrong. You're muted in case you don't know that.
I am enthusiastic about this project, but do not currently have the available bandwidth.
Okay. All right, let's follow up. I'll open a topic on Zulip and see, because Scott's not here. I don't know exactly how much bandwidth it will require, really. We'll come back to it. So actually, can you, whoever's action item, Mark, I guess. Oh, and Josh's notes. Can someone write down in the right places, and not me, that action item Nico to follow up on Zulip about liaison?
Yep.
Okay. So there's another proposal that was opened, allowing the compiler to eagerly drop values. I have been talking some to DJC about this. It's come up from time to time. I don't know when the right time is, but I do think this is something we should be considering. You may recall that we talked about this when we modified async await, the temporary rules for async await, so that they matched non-async await code. And we talked about how if we wanted to have drops that were, if we wanted to make things not outlive awaits, we probably wanted to solve that problem more generally by having a notion of eager drop. And so I thought, in talking with DJC, he had a bunch of examples of problems, that interesting code patterns, and I thought it might be worth kicking off some conversation about whether we want to explore this in any form now. That's all I have to say about it at the moment. I haven't even looked at I haven't had time to read the actual issue, but.
There's also been pretty extensive discussion on Zulip about this. The short summary of which is there are cases that would really benefit from this. There are cases that this would break, and on balance, this is a challenging compatibility issue that we could transition, but it's debatable. Either way, we're going to have cases where people want the other behavior.
Yeah, it sounds very right to me. One thing I was going to comment in Zulip is that we may want to, like, there may be intermediate steps we can take, like, for example, more like must drop lints or must use lints, sort of encourage people to write explicit drops in some cases and things like that, or at least factor out confusing, especially for temporaries. I think there was that paper we saw with the very common source of bugs around match pattern temporary rules, for example. So we might be able to solve the worst problems without any language changes and just by helping people write more explicit code.
There's one other thing worth bringing up from the discussions on Zulip that is one of the few distinguishing factors for the two behaviors. Someone made the point that if we did eager drop, and in particular defined it semantically such that we drop as soon as we can because all of the references to something have been dropped, then to some degree we would make the semantics of borrow checking part of the correctness of the compiler in a way that we have not previously done, because you would need the borrow checker to know when as soon as it's no longer referenced is true. This is not true for end of scope drops, which can do a much simpler rule, but if you want to do as early as possible drops, you could theoretically borrow something and keep it alive and then drop your reference to it.
Yeah, what I will say about that is that there are options. Like, we don't have to take into account references. We could have a rule that says for temporary values, we do some analysis of the control flow graph and decide where to insert the drop. And if you have a reference that outlives it, then you get an error, just like you do today. Like, it doesn't have to be today's rule, but it could be a more intelligent rule without it bringing the borrow checker to bear. But anyway, I just wrote some comments on Zulip to encourage people to summarize that discussion there, because there's no way I'm going to follow all that. And I think we'll come back to this another time. But do you have something to say? Go for it, Taylor.
Yeah, can somebody clarify, is the proposal that we would have like a per function level flag that you would opt in, or is this like a, kind of globally change the default in the future proposal?
I don't think the proposal has reached that stage of specificity.
Okay.
Yeah,
I
there
guess
were two.
I would register my concern with ever having this be like a as soon as possible globally thing, but.
So there was discussion about doing it at the global level of what would this take and what would the impact be. That's still heavily debatable. Separately from that, there are proposals for how to scope it more narrowly, one of which is to have it be a type by type opt-in of this type is eagerly dropped.
That's the obvious thing to me, but yeah. It's still, unfortunately, there would be a number of existing types. Anyway, we don't have to go into all the details. I think it'd be great to get, I would really love to see a write-up coming out of this at the moment. So seems like there's been a lot of discussion.
Yeah, it also seems like it would commit us much more firmly to resolving the temporary lifetimes behavior, which I already feel really uncomfortable about.
You feel uncomfortable about resolving it or about the current behavior?
Oh, I feel uncomfortable with the current behavior.
Yeah, that's kind of where this started, is that I think the current behavior is, well, there are definitely error-prone cases, and there are definitely cases where it creates confusing errors, like both directions. And so we were talking about changing it, and then when I started talking about that with DJC, a lot of the examples he came up with weren't actually temporaries, and so it seemed like, okay, maybe we want to discuss a little more holistically and see where we go.
Yeah, I think I was also thinking of this in relation to there are other existing RFCs about extending temporary lifetimes based on seeing that they're referred to in later places.
Like RFC 66.
Yeah, that haven't ever been implemented.
Right. I still think that's a good RFC, but it needs to be made specific and reasonable. But
yeah, and it needs to be clear that locks can't live indefinitely past their scope.
Anyway,
for similar reason, it has similar issues as this sort of eagerly dropping.
Yeah. Well, not really, but okay, we'll talk about it later. Maybe. I'm not sure I agree with that statement. Yeah.
Okay.
Okay, add const UB RFC. What's the status of this? Taylor, you had some questions. You were not sure it made sense. Did that
I did
go
have
anywhere,
questions.
or did anything change since last week?
I asked questions and people responded. I haven't yet had a chance to read again. It looks like there are some comments, some new comments as of minutes ago. So it seems like there's been like ongoing discussion and I haven't followed it super closely. So
the one quick aspect of that is I believe that your concern has now been addressed, but you should review to determine that.
okay.
The clarification that you were seeking, I think, has been added, or at least one of them, that it is not a violation of the RFC to add an option to not do this if we want it for, say, performance.
Okay. I mean, I think I'm not sold on the motivation of this RFC, but there are a lot of smart people who are. So I think I feel like people have heard me, so I'm fine resolving my concern.
Can you state that, Josh, in a way that doesn't involve a lot of double negatives? What was the clarification?
Yeah, so I had asked, or sorry, a suggestion in response to sort of my concern about the potential impacts on our ability to provide like a more performant Rust compiler that didn't have these UB checks in the future, was that we could add a flag to the Rust compiler that said, hey, don't do these UV checks, basically. And there was some back and forth on, like, I was under the impression that such a compiler would then sort of no longer be a spec compliant Rust compiler based on this RFC saying that Rust compilers must issue errors in these certain places. It would sort of be like a Rust compiler that you had a flag to turn off borrow checking. But it sounds like that's not the way that people are thinking of it on the thread.
That does sound confusing to me. Now I want to add a concern about your clarification.
There is
it guaranteed or not guaranteed?
Yeah, I feel like I'm just totally not sold at all on the idea of having this be like a spec level guarantee. It seems like something that we just want to have as a feature in the Rust compiler and don't really want users to rely on at all. So I don't understand quite why we're introducing a guarantee about it, but.
It's my reading of it is that it's only intended to be deployed, like in terms of we would actually catch everything that where the behavior isn't something that has some obvious semantic attached to it. That's the only place where Ralph is intending to add a guaranteed check, as I read it. And at that point, I don't know what the flag would mean to try to opt out of that.
I mean, there are a bunch of optimizations where we would just assume that those cases don't happen, right?
Yeah, I think my interpretation of what Ralph and Ollie have said is that sort of for some of these checks, there's not, like, other than sort of jitting or whatever the mirror, and then sort of running it at compile time, there's not much you can do without sort of being able to detect them in sort of an interpreter fashion. And so sort of it's relatively hard to add the flag as a, like, the optimizations require a significantly different type of compiler.
I don't think I agree with that. I think there were several easy counterexamples like in the RFC itself talking about like if you were to run mirror optimizations before running things through, like,
Okay, yeah, I guess that's a different, in some sense, kind of optimization, but yes, I see what you mean.
Yeah, it's not that you just like wouldn't check the value of like whether or not a pointer is a number. It's that like you would potentially eliminate some of the code that was performing undefined behavior, right? Yeah. And so promising to check that happens means that you're not eliminating that code.
Yeah, I would say my personal feeling right now is that I don't feel clear on exactly what the RFC is promising. I think in some sense Taylor's concerns, at least my reading of them, are still unaddressed in some sense, but I have not closely followed the discussion. So
So I think it sounds like there are two concerns here. I think one has been addressed and one has not yet and needs to be further discussed. The concern of are we allowed to make these things optional in the compiler has been clarified in the RFC that yes, we are, and that doesn't break any kind of spec the RFC is trying to provide. There's separately the question that seems perfectly reasonable of, is this something we're trying to define as part of the language at all, even if it's something you're allowed to opt out of? And that's a reasonable question. That the RFC has a position on it. It sounds like, Taylor, you're saying that you prefer a different option, and that's still an open question then.
Can someone make the case to me why a user would ever want us not to detect UB? It's just compilation time?
Compilation time, yeah. That would be the biggest reason that all of these things may require stepping through with MIRI, for example, and at some point people may do const evaluation or similar that is sufficiently large and complicated that it needs to be compiled or JITted or otherwise done something for performance in a way that makes it not trivial or not even possible for us to detect certain types of UB.
I also think that there's an argument from compiler uniformity. Like we haven't very well spec'd out a lot of like what some of the mirror optimizations we're going to want are, but I could imagine, certainly that there are mirror optimizations that we'll want to do that have not just, they're not just optimizations in the sense of that they're guaranteed behaviors in terms of like NRPO and things like that. And if we have to sort of like lift out, which ones of those are and aren't allowed in const eval because they're potentially going to cause us not to detect certain classes of UB that we've promised to detect, I feel like that would, and then we wind up having to like special case what mirror passes run in, when doing const eval and which ones don't. Like that would be an unfortunate world, I think.
Yeah, okay. I guess I'm just, okay. I don't have a problem, like keeping our options open seems okay. I'm just thinking about how, from what I can tell, the major value proposition of Rust is that we bring safety and predictability to systems programming. And I'm worried about saying, but not when you're doing it at compilation time.
Not when you're doing.
We pointedly
unsafe
don't do it at
things.
runtime right now, and this is detecting more things at compile time than we currently do at runtime.
I know, but I mean, we do it, like in theory, we do it at runtime in practice, right? That's our goal.
Sure. Well, I think that's actually where we should be with the RFC, and I'm wondering if there's phrasing that could get us there, in that it's not that the RFC should be saying we must always detect this unless the user specifically wants to opt out of it. I think it's reasonable for the RFC to say it is desirable for us to detect these things whenever possible, and then there are multiple reasons why we might not be able to, but it's reasonable from a language perspective to say these things are undefined. In practice, you shouldn't do them, and we will catch them whenever we can. That's a useful language level statement.
This applies only
Yeah.
to like unsafe code that's being interpreted.
Correct.
Okay.
Yeah, I think my overall feeling is very much what Josh said of like, I totally understand why, like, as a user, this would be a nice thing to have, and like it would be cool that my compiler does this, but I don't want to go on like Reddit and see somebody responding, oh well, that this code isn't doing UB because it const evals properly or something, right? And this RFC says that we won't const eval like without an error in these cases, right? And I feel like that's sort of an inevitable conclusion of like specifying this behavior is that somebody like uses it to conclude that their code doesn't have UB, and I don't want that.
I found the parity argument persuasive. And Taylor,
argument?
The argument.
Oh, parity C++ or whatever.
No, parity of sort of runtime, like const eval and runtime do the same thing. We do the same optimizations. They generally behave the same. And one thing I would add is that I want us to have a cargo test -- unsafe or something, which interprets your code at runtime and detects UB, maybe not all UB, but most or whatever. And you could imagine that if we did have that it may also affect compilation time, kind of. I don't know.
We actually do have a cargo MIRI or similar that will run your runtime code through MIRI and scan for undefined behavior. It'd be fun to have a faster version of that.
No,
but,
I wanted to use Valgrind. Yeah, that's.
I see.
Cargo,
Okay.
Cargo MIRI is nice, but it doesn't work with C code. I want something
Got
that
it.
works with like your actual code.
Understood.
But yeah, Cargo MIRI is the right idea. Just I want a more generalized version.
Yeah, I
What
guess.
does parity mean when you talk about nasal daemons? Like at that point, a compiler errors and it is parity, right?
What?
Well, I'm asking. So you said I'm interpreting your statement about parity as being against this RFC in some sense, and saying like, we have the same behavior at runtime as a compile time, and this is adding some behavior at compile time that isn't exhibited at runtime. But my counter argument to that is that the very nature of undefined behavior in many cases is meant to be interpreted as, demons coming out of your nose. And at that point, I think compile time errors are reasonable, right?
I think nobody's against compilation time errors.
So maybe I don't understand the parity argument, the point you're making about parity then.
Sort of that
The parity argument isn't can we catch things at compile time that we would otherwise have to live with at runtime. The parity argument is this is behavior happening in const eval that we are currently detecting at const eval time that we wouldn't detect if the same code was run at runtime because we compile it instead of running it through MIRI.
And so that's not parity then, right? I feel like I'm struggling here. I don't know why.
It's confusing. I'm not sure if the argument, now that I said it out loud, I think the argument as I understood it was, right, that I was thinking of it more like that we will do the same set of optimizations and things like that. And that if there are, you could imagine that meaning that some code will run well at runtime, but not at compilation time. If we weren't doing the same optimizations, right? Or things like NRVO or whatever that may be very important to your overall performance.
Right, there's a general class of like guaranteed optimizations that we would want to offer also to CTFE, right?
Okay, so is that a way of
things that rely on certain classes of UB not existing, then they should be able to do that.
Okay, now I think I'm at least getting closer to what you're saying in terms of, so it sounds like you're saying you want to use this as an argument for saying, look, we shouldn't have to do these checks on the unoptimized mirror. We should be able to still apply mirror optimizations and still run this checking form thing. And yeah, it may not catch some things that are optimized away, but that should be allowed.
That's the argument I'm hearing.
Guarantee that we catch those things. We should say we do our best and like we will try and catch those things, and maybe they're in the future it turns out that we don't have to sacrifice performance or guaranteed optimizations in exchange for that. But I don't think that like giving a guarantee that we will catch these things now seems like it's adding very low to like no value to me in exchange for limiting our options in the future.
Except that it means, well, I can see the value. I can see the value it adds that in the future, like a change optimization suddenly means that somebody who previously wasn't hitting a check starts hitting it, and they'll file a bug saying you regressed my code, right? And when we'll say, well, that was a UB, that was your fault. But still, I can see value in being more upfront about it and saying, look, we're going to catch it eagerly.
The other argument against this RFC, and we should probably move on after like in a few minutes, but is when the other argument is that it's misleading. It's unclear what users still can't rely on us to catch most kinds of UB, let's say. I don't know if that's true, but there are certainly a long list of things that are not caught and a short list that are, right? Depends how you weight them. What is most UB?
The intention I thought from reading the text is that the long list was meant to entirely contain things that were quote unquote non-consequential and had obvious semantics. I personally don't agree with that for unaligned dereferences. That doesn't
make any sense to me. I guess I saw that comment, but I don't understand what it means. Like UB is helping UB be unconsequential.
Obvious semantics of undefined behavior seem like we're doing unfortunate things.
Exactly.
I mean, that is, but I think that's the only way to interpret what's being put forward.
I thought it was saying there are some cases like that. There are some cases that there's no obvious way to make MIRI continue, right? And it's what it says. All of this UB is that there has in common that there is no obvious way to continue evaluation, even though the program has caused UB. Versus the other class, there is an obvious way. Okay, I mean, I guess that's what you mean by inconsequential.
That is what I think. I didn't say that. I'm just quoting what the RC said. I took issue with some of the wording.
It says obvious, but yeah. I mean, I guess in the end of the day, it seems like if we said that it's when you have UB, the compiler may opt to produce an error, but is not required to, then if there's no obvious way for MIRI to continue, it doesn't have to. It has that option, but it's easier for people. But we're not sending the message to people that they can rely on. We're not sending a kind of complex message where we say, you know, you can rely on some kinds of UB, but not others being detected and so on.
Right, and Ralph has all this interesting language in the RFC and like in the discussion thread about like users can rely on it, but not authors.
Right.
So like you can rely on it as someone using the Rust compiler, but not as someone writing code, which I think is a distinction that is really subtle.
I still don't fully understand it.
I at this point, my interpretation of that phrasing, although I'm kind of unhappy with Ralph's response to Mark's question about this, because he seemed pretty dismissive of the question. But my interpretation of it, as best I can handle, is that consumers of unsafe code are like the expression context that unsafe blocks appear within. Maybe that's wrong, but that's my best guess is what that's meant to convey there, versus authors of unsafe code are the things inside of unsafe blocks.
So the question that I specifically asked is whether or not someone could write a library that performed a specific kind of UB in response to, as a way to guard against like undefined behavior at runtime, for example. So giving you a compiler error, when you trigger this, and Ralph said that wouldn't be a valid use of this guarantee.
I think it's
talking like similar to the approach where you define a static assert by defining a type whose size is 0 or -1, that kind of thing.
Yeah, that's what I thought it probably meant by it. Yeah. So I think okay. I can leave a comment, but my current position is that Taylor has persuaded me that what we should do is say officially UB is UB, whether it be at compilation time or at runtime, and like we try to report compilation errors, but it is not guaranteed, and the exact set may change over time, and the rest of it is like implementation advice.
And that one manifestation of UB in const code is allowed to be compiler errors, not just weird values.
Right, correct. Compilation errors are allowed and encouraged, but not required.
Yeah, I do think I know whether I don't know whether this is correct, like per the C++ spec, but I know that in the past I have had the impression that sort of people in the C++ world sometimes say, I'm going to annotate all of my functions or whatever with const or whatever, I think const expr, and then if my code runs through the compiler and on my test cases, then presumably I haven't had any UB anywhere in there, and that seems like a pretty bad position for us to be in, because what we really want to say is like you need to run through MIRI or like Nico's grind idea, which seems a lot more reasonable as a sort of claim. Like I agree that we would love a position to say, if you run this tool, you're guaranteed to be fine, at least on the inputs you provided. But
even then, you're probably not guaranteed because of all this stuff around optimization. But you're getting there. You're getting a lot closer.
Yeah. Depends on what your tool guarantees. But in any case, it feels. I agree with. I think Taylor said that it feels pretty bad if people start thinking that the compiler will catch things and start relying on const defend as sufficient to guarantee no runtime UB, especially with these sort of inconsequential or obvious cases.
Yeah, I do see the point, though, having reread that. I see why someone would call it inconsequential to ignore alignment requirements, for example. But
yeah, I think the main thing that scares me is that like I would not expect if I have a const defend function that like removing const from it would all of a sudden introduce UB into my program if it's still compiled. And it feels like in some sense with the guarantee we're offering here that like we will just,
I don't
happily
think that
compile.
is true. It may
one
feel
note
like
on
that, but I think it actually wouldn't. Under this RFC, like this RFC only applies to evaluation happening at compilation time, and if you remove const, there can't be any. So,
Right. I would think in particular that removing const should always make it less strict. We're never going to have more checks at runtime than we do
Right.
at
I'm
const eval
saying that
time. The other way around would be an issue.
if you previously annotated it as constant and somehow it was promoted or something, then by removing the const, you now have runtime code, which in theory has to be safe against UB, for example, from an unaligned pointer dereference, whereas a const eval time, because you previously had const, you didn't have to worry about that case, and so your code was correct in some sense.
I see. That's interesting. That's a good example to note down.
Was that code incorrect if run at runtime through the const fun?
Yeah, sounds like it was.
It was, but you can make the claim that I never intended to run it, and maybe it was never run before. But if you drop a call to it,
right? Because
Yeah.
const fun isn't const only fun.
Right.
Mark,
Yeah.
to clarify, your concern here is about sort of the other comment in this, not about that we generate errors on UB, but that we sort of kind of happily allow like
Right.
UB with sort of interpretable semantics.
Yeah.
Right.
So if we start allowing, if we error on some cases, but we don't error on other cases, then it seems like there's an easy case of I expected this to work because I saw errors, and maybe I didn't even read any sort of spec or documentation,
Right.
but I saw some errors, and now I dropped const because I needed, or I didn't even drop it, I just called it in a runtime context, and now I have UB in my program.
That seems likely. Like that's just going to happen, right? Nobody's proposing anything that prevents that from happening, whatever we do in this RFC.
Well, I mean, we could ask for an amendment that says, for example, that the compiler errors would say at runtime or at compile time, we caught some UB in your program. We should introduce like a help message that says, hey, by the way, we don't actually catch all UB, but.
This actually gets at something I wanted to bring up, which is there's a meta question here of whether this should have been a compiler team RFC rather than a Lang team one. Like, I don't know the answer to that, but I think some of Ralph's frustration is that they were sort of advised to make an RFC to get some of these ideas down. And it's not clear whether they actually really meant to try to be proposing language level changes as opposed to like just documenting a design for something that would go in the compiler.
Well, that may be. This does feel like a language level. I feel this is appropriate to have a Lang team RFC on this topic, though.
Yeah, if that was the purpose, then I feel like this was mistargeted, because I do read this as like a language level RFC, right? It doesn't
even after adding the flag, like to me, once you add the flag saying we'll just disable it, like disable these checks, then
I mean, that's my initial comments were all prior to the whole flag thing. The flag thing kind of makes me feel differently about this. I mean,
I think right. So if the Lang guarantee that I proposed and that I still favor of, which I think Taylor also favors, we're not going to guarantee you anything, and then having this current context more or less be like, this is just documenting the current behavior of REST feels fine. So as a compiler team RFC against a Lang team baseline, which is like, we left this to the implementation to figure out.
I think it's more than just like, I mean, I don't think it's meant to be just current documentation. I've been thinking more of like was meant to be a tenant, like something where it's not a guarantee, but more something we strive for and to help us guide future decisions, and to be positioned accordingly, which is sort of what we talked about already, right? To say that like, yeah, these are all nice to have, it'd be good to make that up front, but it's not a guarantee we ever make.
Actually, there's a concrete parallel I think is worth drawing here. Our handling of overflow is not just a compiler thing, that's a language level thing in the context of, should it be a language property that if we could, we would catch overflow in general. And there is an optimization that we don't in release mode because it substantially impacts performance to do so.
Yes.
If
Right.
we could do so for free in release mode, we would. And that's a language level decision.
Yeah.
That's not just a compiler decision. I think that's
Okay.
what this is as well.
I also feel this is language for the same reason.
Yeah, we're
Okay.
effectively saying this is important. If this were free, we would always do it. Because it's not free, we may or may not always do it, but we're still stating that we consider it important and we would do it always if we could. That's a language
actually-
level decision.
And that we should totally move on. However, this continues to be productive, which is frustrating to me. I do think that precedent, I had that in the back of my mind and then I dismissed it, and I'm glad you said it explicitly, Josh. Like, it makes me wonder if maybe I actually sort of the precedent I would want, that like in debug mode, we will catch all those things. I don't know, something to think about.
Oh, like cargo, like run debug is Valgrind?
Like cargo, no, like
Cargo check.
well, I've thought if we had that cargo, I always say cargo test -- unsafe, not to scare people, but and that's probably what we actually want. But if we had, actually had this Valgrind thing I'm talking about, it would like be cool if cargo test, if your project contains unsafe code, or I don't know what, but sometimes I imagine there are projects that would want it to be the default. Right?
Just would run the UB sanitizers and things.
Yeah, but in any case, what I meant was like you could imagine that. I don't know if what I'm saying makes any sense because debug is supposed to be fast compilation time, but I'm just saying like the argument that we used when we made this decision about overflow was that checking in debug was kind of good enough because it is at least sometimes guaranteed to be a panic, and somebody's going to be running and testing your library in debug mode and subserve this panic. Like you know what I mean? And I'm not sure if that argument, I think that is largely borne out for me.
There is the other detail about the inner overflow where we actually do guarantee a particular semantics for what overflow will do.
Yes, we do. Yeah, that's another detail we say. But I guess, yeah, I'm just saying it would be nice if there was a way for me to say, I don't care. Like, yes, I understand sometimes compilation needs to be fast and it may not always be detected, but at least like while I'm testing and doing development, I will detect these kind of problems.
I still think even in a world where we have like UBSAN and TSAN and MSAN and like all like Rust integrated and stuff, I still would be cautious about like promising that if that tool returns okay, that your program has no UB in it.
I don't think we can ever promise that. Yeah.
Right.
Yeah, I don't think that's
and that's the sort of direction that it feels like this RFC is heading to me, where it's like guaranteeing that if your thing compiles, that it doesn't have these specific classes of undefined behavior in it.
So it sounds like that's what we want the RFC to clarify, that this isn't saying you must detect all UB. This is saying if we could, we would detect all UB, and we will detect what we can and report it.
I think we really have to move on. I'm going to put down my foot, but because it's time, because we'll never
is there
get
action. Well, wait, is there action here? Hold on. Is there an action item on this RFC?
Comment on the thread, probably.
I think there's an action item for all of us to leave comments. Yeah, it seems like everyone has thoughts. We should be engaging. I'm not even sure that we have like a clear summarize. I don't know that we came to an internal consensus as a team.
Yeah, I think individual action items make sense right now.
Yeah, that's what I think too.
I will make those happen.
Appreciated. All right, I wanted to bring up RFC 3067. I think we're not going to do this pub macro rules thing for the addition. I think we should just close this RFC.
We FCP'd it, I think.
Oh,
right?
great, perfect. Never mind then.
I think.
Okay, pending postpone. I forgot to actually look at its status, I guess, before I wrote that. Okay, check your boxes then.
On this one, is there something we could reasonably do to make sure this resurfaces later after the addition? I think that we have a tendency to postpone things and not have any kind of tickler for later to remind us, hey, this was a thing we cared about at the time.
We don't have a mechanism for that. I don't see a reason that the work that, like, I think we could continue that work could continue. It's just not going to change. We're not going to change the default for the new edition, right? It could continue as a feature gated feature. That would be okay for me. I would like to have a registered project for it. I was going to ping Ryan about that.
Okay.
But I want someone. I'm happy for it to continue if somebody's going to continue it. Is kind of the thing.
Can we add an action item for you pinging Ryan about that?
Yeah, let's do that. Thank you. That would help me remember.
Yeah, and Nico, I will also make a note that in the previous discussion, I think without you on that RFC, and I reflected this in my summary comment, we had discussed that potentially, and I at least was opposed to experimentation on nightly, even though we can continue exploring the design space for sure.
Okay, interesting. We can talk about that later then.
Yep.
I wouldn't be, but that's all right. RFC, declarative macro metavariable expressions. I think this is pending. There's comments, not a lot to say. Unless anyone has anything they really feel they want to say.
I think there are
The
also
author's
action items
making
for
some
remaining
updates on
people
the
to read
weekend.
it.
Say that again. There's action items for folks to read it, Josh said, and Scott, you said.
There's a comment from the author that he's going to make some updates over the weekend, although I don't think there's anything that would block people from reading it.
Got it. Some small updates pending. Okay.
Actually, I have a quick procedural question on this one. Should this also be a libs RFC? Because what it's actually introducing are like they're built-in macros, but they are like library macros. Like they're things that people use to write libraries, and they're part of the standard library. It seems like it would be good to loop in those folks for their thoughts.
That's an interesting question. So these are effectively intrinsics because they aren't going to be implemented as library macros. They're going to be implemented as built-in mechanisms in the macro interpreter in the language.
Correct. I guess I'm just thinking also about the people on the libs team and like.
Definitely would think
I
pinging
basically
them.
want people to review this.
Yeah, let's at least ping. I mean, I wouldn't want to. I don't think that it. I do think it's a laying RFC, but I think we should ping the libs team.
Yeah, can we make this like blocked on DTOLNE review or something?
It's okay. Make a concern. You have the right to make a concern.
Actually, I'd be happy to take the action item to ping and summarize for the libs team.
That would be great. Thanks.
The side of this that I guess I was sort of commenting in one of my comments, and Taylor's thing is hitting the same kind of thing, is how much does this want to be magic syntax, and how much is it that people want to be able to write macros that take macro packs, whatever those are, and just have these be able to be something that's in the standard library. Like one of the comments I put on this is, what would this look like if it was just a count macro that was implemented to be really fast as a magic compiler item versus needing to be syntax? At which point, it could turn into, these are standard library items that have a libs-impl conversation about this one should be really fast.
Do you think, I'm not sure everything here could be expressed that way, the index stuff in particular.
Yeah.
I don't know.
The index would not be possible.
Yeah, I don't think
anything that's passing the variable instead of expanded tokens can't work like that, and a couple things, but
also length.
Is index clear to y'all as a name for what that thing does? Is like quick. I feel like it was not intuitive to me. Like I understand now what the behavior of index is, but like index is a surprising name for that thing to me, but maybe it isn't to others.
It's exactly what I would expect, I think.
Yeah, I found it to be clear. The only question I would have is what happens when you nest it inside multiple levels of repetition?
It has the depth, but yeah.
Oh, it does have a depth parameter?
It can, yeah.
Optional.
It's optional.
Okay, then yeah.
If it makes sense to everybody, then that's great. I'm glad.
Yeah.
It has some pretty good examples of it, actually, of like, here's showing a multi-level recursion with what all the indexes are and stuff.
Yeah, I understand the behavior. I just that was a surprising name for that thing to me, I think, but I understand why it wouldn't.
Taylor, what is an example of another name?
I have absolutely no idea. I don't have.
Oh, okay. Well, we might have immediate alternative.
like, yeah.
Yeah,
I'm totally fine with that being the name, and I don't have any like better suggestions.
I'm not like, yeah, exactly. I'm not wedded to it, but it's the name that I would, if I were going to make a name, it's probably the name I would make. Okay. Yeah, I guess, Scott, is that a blocking? That I personally feel like I'm persuaded by the fact that these can't all be functions and they require a bit of context from that can only come from the interpreter, that special syntax is okay. But
yeah, I don't think it's blocking. I put a comment and I think they're going to add some text to the RFC saying a lot of the same things that were raised here, at which point we'll be like, okay, that's a good reason.
Yeah,
Um,
it's good to have it well motivated. I definitely agree with that. All right.
Yeah, it just sort of opens the question of like how many magic functions like this are we going to want to have in there, and what's the rule for having them? But that we can bump that for later, I think.
Yep.
I think it's safe to say that we would hesitate to do this for things that are easily done as a separate macro. And the rationale for all of these is either they're many, many times faster and couldn't be done otherwise, or they can't be done.
Sounds right. They're also all related to counting, almost. But okay, repr C is unsound. There's been a bunch of new comments. Is anyone following this topic? What's going on?
I've been following this. There is a lot of discussion here. A fair bit of it is unpleasant. I will provide the caveat. But that aside, there is currently debate over whether it is possible to change repr C without breaking existing code, or if repr C is sufficiently widely used and expects current behavior, that we would have to introduce a repr really C or effectively equivalent. Nobody suggested a concrete name for it in the RFC in the thread, but effectively we need a thing that is match compilers exactly. Changing that will involve changing the handling of zero-sized types and similar, and there is some existing code that uses zero-sized types and may, we're not clear, have expectations on that.
There are a bunch of examples I think I saw that bindgen does this, which means it's prevalent as well. That seemed interesting.
What does it do in particular?
It's using these for alignment effectively. And the fundamental difference that is the most common thing being requested on this thread is that zero-sized types that are repr C and have an alignment are represented as something that isn't zero size if you're on MSVC and nowhere else. And that changing that would break code that is using a repr C aligned type just for alignment and expects it to stay zero size. So we need to find some way to make that work in both cases, and that either means adding a new repr or figuring out if we can fix this repr without widespread breakage.
Okay, so I guess the current status is that we'll continue to monitor.
Just to clarify on the notes, it's repr C ZSTs that have a specified alignment, right? That's the thing that's under discussion.
That sounds right.
Yes.
Last time I remember we discussed this, we had a bunch of back and forth about what happens in the case of like a non-repr C ZST in a ZST or in a repr C struct, and that was sort of a different thing.
Yeah, okay, that's right. Okay, I've added a new section, by the way. Things in the reference which are tagged as nominated will appear here. There aren't any right now. Trying to build some more connections between the reference and our triage. Never type. We have not very many minutes. Do we want to go into this, Mark?
Let's skip for now, and maybe Nico, I'll schedule a meeting with you, and we can dig in before we discuss.
That sounds good.
Time we have.
Okay.
Yeah, maybe we can jump to one of the ones we're likely to be able to resolve in 6 minutes.
Yes. There's a, okay, this is weird deprecation of nesting items. There's a pending FCP close. Is there a place to put things for 2024? Not that I know of. I think we have an addition V next or something. We could just keep it, but
I mean,
it's
the
fine.
place to do this is like get a working group together and write an
Yeah,
RFC.
that's what I think too. If you want to do it, do it. But okay. So field is never read, lint warning. I started looking at this link and I was like, was this complicated? And it's got a lot of examples and I don't know what's the exact thing. So I was wondering if somebody wants to take an action item to write up what the heck is going on here and summarize it.
Sorry, which one again?
Oh, sorry. This one here, 81658, field is never read, lint warning.
Thank you.
I think, I can't quite tell, but there seem to be at least two things going on. One is like a lint that's warning, but there is a read, but that read is in an FFI function that we can't see. And the other is, I think that there's a destructor, and
Right. It's never read, but it's useful
never,
to store to it because it has a drop.
That's right. That's right. And they want to make the drop run at a certain time. I don't really have, I don't know what my opinion is about these things.
I think in both of those cases, my inclination would be to say this is why we have underscore fields and the ability to turn off lints. But if there are any cases where the read in Rust code is not caught, that's another matter.
I think I feel the same.
I've seen a lot of code in various projects that has an underscore field that is intentionally never read, and there's a comment on it saying, we're storing this so that we drop it later.
Yeah.
But if there are any cases other than those two, I think they'd be valuable.
They said something
I
on
think there'd
safe
be
code
value
here.
in catching it.
They mentioned
Yeah,
unsafe code as
The
another
unsafe
place.
is about FFI. So the common thing is you have a RC struct, you put a field in it, and then you never read that field, but you pass it to some FFI function, and that reads it.
I think I'm going with my usual rule of thumb is like, I don't mind if the lint flags something where I would really want to comment. I'm trying to decide if this categorizes here plausibly. I definitely think that it's only stored to so it can get dropped later probably merits a comment.
Does the underscore field name disable this?
Yes. It feels okay to me.
Yeah.
Like,
yeah, I don't know why the auth
I guess
PR filer is so concerned if it's.
The other question is, what do we lose by not, like, we kind of can never warn about unstored fields, right? Like, especially the FFI, we can't really know if you're going to pass this to some FFI code. I mean, it would basically mean any RC we never warn, right? And that seems too broad of a brush.
Or escape analysis for something that goes to an extern C function.
Yeah, that's over the top. We can't even see it. First of all, yeah, first of all, it's a lint. It's not like a global analysis. And secondly, we don't know that this may get used in other crates.
Yeah.
Probably if it's pub, we probably don't warn anyway. But
the suggestion being made is that if there's the address of the field is taken, then we should not warn. Specifically, but
I'm okay with that.
Address of or reference to?
Address, like specifically casting to a raw pointer, I think.
That actually seems reasonable. I was going to say taking a reference, I would still like the lint to detect if that's never used, but if you're turning it into a raw pointer and passing it off to something, that actually sounds pretty reasonable to turn that off.
We can't detect that, but
yeah,
we could make a best effort. If they use the raw ref macro, we could detect that, which they ought to.
Right.
I would be fine. Okay, so I think fine with disabling the lint if we see a raw pointer being created. I guess I also feel like I'm surprised that borrowing doesn't consider to
That's-
read. How could
yeah,
you
that's my
possibly,
question.
like, we don't know where that borrow goes, right?
No, but it's the borrow of the not of the field. It's just a borrow of the struct that contains the field, right?
Oh, okay. I see.
And so
Are we opposed, just as a quick check, to reverting the PR that like broke this, just so we have more time since it's currently a beta regression?
I'm kind
It's
of
just a lint,
opposed.
right?
Didn't it fix something? Why did this PR land in the first place?
Made another false positive, false negative happen.
these don't feel like false positives to me. They're
Right,
fields
these-
that aren't
I don't
read
know.
from rest.
That's
These are
kind of
like
how I feel
other-
too. These feel like,
Anyway, I guess we're over time, so
yeah. I'm somewhat opposed because I feel like we're pretty close to saying this is a won't fix.
yeah. Well, I don't know. I guess we can discuss more next time. Maybe someone can write up a more concrete
Yeah.
summary of what exactly is going on.
Who wants to do that? And then we gotta quit.
I feel like to clarify that last bullet, I don't feel like that's something we can actually do, because what you're really saying is we would disable the lint if we see a raw pointer created to anything that recursively contains.
Yeah, it
a
seems too
that
hard.
field, right? And that's too.
True.
I think that's
I
too
think-
broad of a brush.
I agree. I didn't realize quite what it meant.
I like this should have an underscore name argument. I could, if that's our takeaway, I'd write a comment. I can write a comment for that.
I would like you to write a comment, Scott, and it would be great if you summarize all these points that were made. Well, in particular, taking a borrow that becomes a raw pointer requires
Yeah,
checking all
the general
containing
idea of
things.
like allowing this through would allow so much through that it would make
Right.
the whole lint basically useless.
Reading the comment thread, it sounds like part of the problem is the diagnostic doesn't suggest putting an underscore in front.
That seems fine. I thought the diagnostic did, but
I don't know. I haven't seen the text of the diagnostic yet. It's more the person said they object to the Rust compiler giving an error without telling you how to work or how to address it. And they said in this case, all they're seeing is you can remove the field.
okay. So let's encourage the diagnostic to put an underscore if it doesn't already.
I can, yeah, okay.
All right, Scott, why don't you write a comment? We'll see how they respond.
Cool.
Sounds good. Thanks, everybody.
Bye.